So my claim, I am wicked awesome at free throws. I'm an 80% free throw shooter. To prove my skills, I shot 50 free throws and I made 32 shots. Am I exaggerating my free throw skills? Or am I actually an 80% free throw shooter? Right. So to start off with, what would the population be here? All the free throws that I could make, all the free throws that I take. All my free throws. What would the parameter be? That wouldn't be my parameter. The true percent or true proportion of, yes, of free throws made. Perfect. So population, all the free throws that I shoot. Parameter is the true proportion of free throws made. So if I'm really an 80% free throw shooter, then that would be an 80%. But I don't know. What would the sample be here? I'm sorry, what'd you say? The 50 free throws I shot, and the 32 over 50 would be what? That's our statistic, yes. So the sample is the 50 free throws. Population is all possible free throws. Sample is just those 50. Parameter is the true proportion of free throws made. My statistic, so p hat, would be the 32 out of 50, or 0.64. Is this sample proportion, is this p hat, supporting my claim that I am an 80% free throw shooter? Did I do better or worse?
Worse.
A little bit worse? Much worse?
A little bit.
So what could account for the discrepancy between what I claim and what happened? Lying, okay. Or we're going to be nice to me and call it exaggerating. So I could be lying or exaggerating. What's the other possible reason that this could have happened? Yeah, I just had an off day. I had a bad day. My thumb hurt. I couldn't shoot that well. So those are our two possible reasons for why I only shot 64% on this day. So to test to see which one of these is more likely to be the case, we're going to run a simulation. We are going to assume that I'm telling the truth. We're going to assume that I just had a bad day. I really am an 80% free throw shooter. I just had an off day here, and that's why I shot so much worse on this day. We call that assumption the null hypothesis. Looks like this. The null hypothesis. It's a capital H for hypothesis, and then it has a little, what looks like a 0, but it's a null. So a capital H with an O or a 0 next to it. My hypothesis is that the true proportion, P, is actually 0.8. The other possible explanation for why this occurred, the other explanation that being I'm exaggerating or I'm lying about this, we call that the alternative hypothesis. So this is a capital H with an uppercase A, a little tiny uppercase A next to it. H for hypothesis, uppercase A for alternative. The O for the null is like a little one. It's like a subscript. So it's not going to look like ho, ho, ho. when we do the null hypothesis, it's a capital H with a little o next to it. And the alternative hypothesis is a capital H with a little a next to it. A little tiny uppercase A. So my alternative hypothesis that I'm exaggerating, if I'm exaggerating, then the truth would be that the true proportion is actually less than 80%, right? I'm blowing my skills out of proportion here. So we have our null hypothesis and our alternative hypothesis. Like I said a moment ago, we are assuming that first option. We're going to assume that I'm actually an 80% free throw shooter. We're going to examine the likelihood that it was just bad luck, that I just had an off day. We're going to use a spinner to do this simulation. This is what you need your phones for. So if you just Google spinner, and you scroll through the first couple options there should be this guy right there. Just a straight up Google spinner, right? You guys all see a spinner on there? All right. So let's decide what means the shots have been made and what means the shots have been missed. We want to do 80%. How many slots should I have on here? What would make the most sense? Like how many sections should we have on the spinner? We could do 5 on the spinner, or you could choose to do 10. That would also make sense. All right, so let's set up our spinner. So I'm going to go to wheel size. I want 5 numbers. Oh, hold on. I got to change the wheel size here. I'm not paying attention to that one right now. I just need 5 sections on my wheel. So now let's define what means a shot was made. Again, we're going with the assumption that I really am an 80% free throw shooter here, right? So what should represent that the shot was made? What'd you say? A 4 or a 5? If we choose 2 numbers, that's what percentage of the wheel? That would be 40%. We want 80%. 2, 3, 4, 5 could represent. All right, let me get my thing back up here. We're going to write down those parameters that we've set. There we go. That took a minute to get back up. So a 2, 3, 4, or 5 would be that I've made the shot. That would be 80%. And a 1 is that the shot was missed. So far, so good? So only 20% of our wheel is dedicated to a missed shot, and 80% of our wheel is dedicated to a made shot. All right, so you are going to do a sample of 50 free throws. You're going to have to spin the spinner 50 times. You need to record the proportion of shots that were made. So keep a little tally going. You're going to need to count how many spins you've got. But out of those 50 spins, the numerator needs to be how many were made. So something out of 50. So far, so good? All right. After you've got that done, and you write down your p hat, something out of 50, you're going to do it again. So you're going to end up with a total of 100 spins, but you're going to do it in 2 separate sections. So everybody should have 2 separate P hats. So far, so good? After you have your 2 P hats, you're going to come up to the board and you are going to put a dot wherever your P hat happens to fall. Your 2 P hats. So you're going to put 2 dots up here. All right, let's take about, I think we should be able to do this in less than 5 minutes. So I'll set aside 5 minutes. If we need a little bit more time, I'll add a little bit more time on there. But let's try for 5 minutes. All right. So here's our dot plot. Scoot this guy out of the way. Let's see, how many dots do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. Of those 34 random samples of 50 shots, in how many of them was the proportion as bad as mine? Like my actual free throws? 0. None of them. My proportion was here at 0.64. So on this line here, I want you guys to write down Ms. Bolt's proportion of shots made in one random sample of 50. So 0 out of, we said it was what, 34 total dots? I think that's what I counted up. So 0%. Yeah, 34. What does each of those little dots represent? One sample of 50. So why are they not all up there at 1.00, 50 out of 50? You didn't just take a sample of 50. What were you recording each time? Yes, it's one sample of 50 shots, and the proportion made. What assumption did we make? So it's not just proportion of shots made, it's proportion of shots made by an 80% free throw shooter. So basically we're comparing me, where I've claimed to be an 80% free throw shooter, to this hypothetical person who actually is an 80% free throw shooter. Our simulation was saying this is definitely an 80% free throw shooter. Let them take samples of 50 shots. Let's see how many they make. Now, I did substantially worse than this hypothetical true 80% free throw shooter, right? Go ahead and flip it over on the back side. We already answered this first part here. We wrote it on the picture, but I'd like you to get it down in the second spot as well. Each dot represents the proportion of free throws made from a sample of 50 by an 80% shooter. Last year, When we were doing number 6, I had a student say each dot represents the proportion of free throws made out of 50 by me. Would that be a correct interpretation of what each of those dots is representing? No. What's the difference between what we wrote for number 6? Not necessarily. I may or may not be an 80% shooter. So those dots are coming from someone who is an 80% shooter. It's this hypothetical imaginary person, not necessarily me. We don't know that I am or am not an 80% free throw shooter. That's what my claim is. So far, I haven't provided much evidence to back that up, but that's what I'm claiming. What percentage of our dots were 64% or less? 0. We had 0 out of 34. So 0%. This number right here, we call our p-value. Sorry, it's squeezed way over there on the side. That's called our p-value. And we've been calculating this value for a while. Do you guys remember in the past when we've done dot plots and we've compared that to the claim, we've said what percent of them were that or more extreme? We just didn't have a name for what that percentage was called. So this is the probability of this just happening by chance, of getting a 64% or less by chance. So interpreting that percentage in context, assuming that I was an 80% free throw shooter, there's a 0% probability that I make 32 out of 50 or 64% of free throws or less purely by chance. So if we're saying this 32 shots out of 50 happened purely by chance, that would kind of equate to I just had a bad day. It was just an off day. It was this random event that happened. There's not a very good probability that this was just random. What's the more likely explanation for why I only got 32 out of 50 shots?
Your percentage is lower than 80%.
That I'm not really an 80% free throw shooter. The probability that this just happened randomly when I really am an 80% free throw shooter is not very high. I'm going to pop all this a little bit higher on the screen, so give me just a second to get it up there for us. There we go. So based on that answer, do we have convincing evidence that I'm exaggerating? Yes. What's our benchmark percentage that we compare things against? 5%. So I would say we have convincing evidence that Ms. Bolt is exaggerating Yep. We would have had to have some percentage of shots that came out to be more than 5%. So as we did this spinner activity around the room, at least 5% of those, preferably 6 or 7%, should have come out to be 64.64 or smaller. Then it would become more believable that I just had a bad day, that I really am an 80% free throw shooter. I told you I hurt my thumb, and that's why I was having this bad day, right? So we have this convincing evidence. It's unlikely that an 80% free throw shooter does this poorly just by chance. I'm going to scoot all my stuff up a little bit higher because I ran out of room. It's believable that an 80% free throw shooter has a bad day, right? I'll come right back to this, but I want to pause those of you that are copying this down for just a second, and I want to look at our dot plot again. If I had shot, say, a 72%, would it be more believable that I just had a bad day? Yeah. We have 4 shots that are 72% or lower. So that's more believable that I just had a bad day. What about if I had shot a 74%? Even more believable that I just had a bad day. Our percentage is increasing here. When it's a very low percentage, the chance that it happened, or the possibility that it happened purely by chance, is very, very low. That doesn't mean it's impossible. Just because we came up with a 0% chance doesn't mean that it's impossible that I just had a bad day. It just means it's highly unlikely. The more reasonable explanation is that I'm blowing things out of proportion. I'm playing up my skills more than I should. This is an introduction to what we're calling significance tests. We're going to be looking at proportions, so P and P hat again. But instead of creating an interval, we're going to run a test to see whether or not the null hypothesis, what's being claimed, is likely correct, or whether another explanation for what we're seeing is likely correct.